In this video, we will be discussing Pascal's law, also known as Pascal's principle, or the principle of transmission of fluid pressure. The law was established by the French mathematician Blaise Pascal in the years between 1647 and 1648. This principle is a principle that deals with fluid mechanics, and it states that a pressure change occurring anywhere in a confined incompressible fluid is transmitted throughout the fluid such that the same change occurs everywhere. Pascal's principle can be used to describe the fundamental characteristics of fluid, and it provides the foundation for hydraulic systems found in barbershop chairs, construction equipment, and the brakes in your car. And so because the force applied to the contained fluid is distributed throughout the system, you can multiply the applied force through this application of Pascal's principle in the following manner. Now assume you have a closed container filled with an incompressible fluid with two pistons, piston 1 and 2, and they have different areas. We have area 1 and area 2, and so if you apply a force to the first piston in area 1, you're going to create a pressure in the fluid that you can call P1. So that by doing this, this pressure will equal the applied force divided by that first area. Similarly, the pressure at the second piston over here will equal the second force divided by the area of the second piston. And since the pressure is transmitted equally throughout the fluid, we can come up with a formula known as Pascal's principle, where we have our initial force and area will equal our second piston force and area. Now let's look at an example of how we can apply Pascal's principle to a physics problem. In this problem, we have a hydraulic system, and we have a piston with a cross-section area of 21 square centimeters, and it pushes on an incompressible liquid with a force of 38 newtons. The far end of the hydraulic pipe connects to a second piston with a cross-sectional surface area of 100 square centimeters. What is the force on the second piston? Well, the first thing we need to do is to remember what formula we are using in order to solve the problem. And so we will be using Pascal's principle right here. We need to identify what information has been given and what we need to solve for. And so if you'll notice, we are given our first force as 38 newtons. So we'll write in 38 newtons. Our first area is 21 square centimeters. Our second force is what we're solving for, so that's our unknown. And then our second area is 100 square centimeters. Now we filled in our known information. We do simple algebraic. We solve for x, and so we get our second force as being 181 newtons. Here we have a second example to look at. We have a barber raises his customer's chair by applying a force of 150 newtons to a hydraulic piston. It has an area of 0.01 meters squared. If the chair is attached to a piston of an area of 0.1 meters squared, how massive a customer can the chair raise? Assume the chair itself has a mass of 5 kilograms. Again, we will be using our Pascal's principle formula. We're going to plug in our information. Now, and we can see that our F1 is 150 newtons. We can see that our first area is going to be 0.01 meters squared. Our F2 is our unknown that we're solving for, and our second area is 0.1 meters squared. And so we're going to solve using simple algebraic, and we get our answer as the chair can lift an individual with a weight up to 1,500 newtons. Finally, let's review one last Pascal's Principle problem. Here we have a hydraulic system is used to lift a 2,000 kilogram vehicle in an auto garage. If the vehicle sits on a piston of an area of 0.5 square meters and a force is applied to the piston of an area of 0.03 square meters, what is the minimum force that must be applied to lift the vehicle? In this case, what we're doing is we are attempting to solve for F1. Now you'll notice that nowhere in this problem are we given the force. So we have to go back and remember that force equals our mass times our acceleration. And so we're given a mass of 2,000 kilograms. And our acceleration on this problem is going to be the acceleration due to gravity, so it's 9.8. And so when we do this, we will get a force of 1.96 times 10 to the fourth. So let's plug in our information. We know that our F1 is our unknown. We know that our area 1 is going to be 0.03 meters squared. Our F2 is 1.96 times 10 to the fourth. And our area 2 is 0.5 meters squared. Now we'll do our simple algebraic solution, and we find out that our F1 is going to be 1,180 newtons.